students, welcome back. We're going to continue our discussion of the formed elements. In this lecture, we will discuss the number or the frequency of the individual formed elements in the blood. Before beginning this discussion, I'm going to first draw a dime, the coin. There is a feature of the dime that's going to be useful in helping you to understand the dimensions that we're going to be using. So let's represent a dime here. For our purposes, it's the thickness of the dime that's important. A dime has a thickness close to that of 1 millimeter. So we're going to indicate that here. It's important that you understand what 1 millimeter is. The standard unit of volume for determining blood count is a box that's 1 millimeter wide by 1 millimeter tall by 1 millimeter deep. And so we're going to represent that box here. And 1 millimeter cubed is equal to 1 microliter. This is the volume we're going to be using to determine our cell counts. And so we'll have 1 microliter of blood, and we'll determine how many of each type of cell will fit into this 1 microliter. We're going to present this data in a table. Now, I've tried to draw a table freehand. However, it's difficult to do because I can't draw a straight line using the stylus. So I just created a table in Microsoft Word, and I've pasted it here. And so here's our table. First, let's put the headings of our table. And so here we have the headings of our table. In the first column, we'll have the formed element. In the second column, we'll have the count or the number of those formed elements in 1 microliter of blood. In the third column, this will only be applicable to white blood cells. We'll show the percentage of the particular white blood cell to the total white blood cell count. And in the last column, we will indicate a possible pathology when those percentages are not normal. And so let's next indicate the formed elements. So here we've shown our formed elements: the red blood cells, the platelets, the neutrophils, the lymphocytes, the monocytes, the eosinophils, and the basophil. Now what I've done here, I've put them in order of their number or of their frequency, with the highest frequency being on the top. And so what we're going to do next is indicate the number of these formed elements in 1 microliter of blood. I'm going to say them first, then we'll write them, then we'll go over them again. The RBC count is 5 million. The platelet count is 250,000. The neutrophil count is 4,200. The lymphocyte count is 2,200. The monocyte count is 450. The eosinophil count is about 150. And the basophil count is 50. So let's represent those numbers here. So here we've shown the counts of the individual formed elements. There are 5 million red blood cells, 250,000 platelets, 4,200 neutrophils, 2,200 lymphocytes, 450 monocytes, 150 eosinophils, and 50 basophils in 1 microliter of blood. Now let's represent the percentage of total white blood cell. Because I want you to be able to remember these numbers easily and have an understanding of these percentages, I've rounded these to numbers that are easy to remember. And so for the neutrophils, the percentage is going to be 60, lymphocytes 30, monocytes 6, eosinophils 3, and basophils 1. Let's represent those here. And so here we have our percentages: 60, 30, 6, 3, 1. For neutrophils, lymphocytes, monocytes, eosinophils, and basophils, respectively. Before we discuss the possible pathology, I want us to first graph these data so you can see what it looks like visually. So again, I've just created some straight lines, a table, to use as a starting point. On the x-axis, we're going to have our 5 white blood cells. So let's indicate those here. This is our x-axis. Now let's put our y-axis. So we're going to only be looking at the white blood cells. We'll have our minimum value will be 0 and our maximum value will be 4,500. So let's indicate those here. And so on the y-axis, we're going to have white blood cell counts. So let's indicate that one here. Now we have our grid, our x-axis labels, and our y-axis labels. Now let's add our data. Now we have bars for all of our leukocytes. Now let's make sure we have the correct values now. So for the neutrophils, we have a white blood cell count of 4,200. For the lymphocytes, that should be 2,200. So let's lower this one. Let's put this one at 2,200. Somewhere close to that. For the monocytes, the number is 450. So let's go here. There's 500. So 450 may be there. The eosinophils have a count of 150. It's very low. So 250 is here, maybe 150 is there. And the basophils have a count of 50. So let's go here. So that's 150, maybe a third of that. There we go. And so this table is a graphical representation of the number of the individual white blood cells. As you can see, there are many more neutrophils and lymphocytes than there are of the other cells. Let's indicate a few things here. This table here showing the relative numbers of the white blood cell is known as a differential leukocyte count, or a leukocyte differential count, or a white blood cell differential count. So let's place that title here. This differential count is extremely useful in determining if a pathology exists within the individual. In this last column, we're going to indicate what pathologies are indicated when these percentages vary from what is normal. If your neutrophil count is high, that is indicative of a bacterial infection. If your lymphocyte count is high, this is indicative of a variety of infections. So we can't really identify any one. If your monocyte count is high, this is indicative of a viral infection. If your eosinophil count is high, this is indicative of a parasitic infection or high levels of an allergen. And basophils are typically pretty stable, and so they don't vary a lot when you're doing differential counts. And so we're going to indicate those pathologies here. Okay, let's review these. If your neutrophil count is high, this is indicative of a bacterial infection. If your lymphocyte count is high, this is indicative of a diverse number of infections. So more tests will be needed in this case. If your monocyte count is high, this would be indicative of a viral infection. Now, when I'm saying the count, I'm referring to the percentage, the numbers relative to one another. The differential count is the numbers relative to one another. If all of these numbers increased, the percentages would be the same. So you can't look at the absolute numbers. You have to look at the percentages. If your eosinophil count is high, this is indicative of either a parasite or an allergen. And basophils don't really change a lot in diff counts. And so they're pretty stable. And so that concludes this lecture on the number, count, or frequency of the individual formed elements. I hope that you've learned a lot.